The machines in our bodies have highly detailed structures intended to serve specific purposes. We now turn to the compartment where the grinding process takes place, the stomach. Food enters the stomach through a gap known as the cardia. Contractor muscles in this space that joins the esophagus to the stomach work like a valve and prevent half-digested food returning to the esophagus. Nutrients subsequently move on to the upper part of the stomach, which is shaped like a dome, and then move on to the widest part of the stomach after having mixed with gastric fluid. This wide section makes a sharp turn, thus forming the horizontal part of the stomach. The stomach narrows again in this section, which is shorter than the vertical upper section, and opens onto the duodenum through a passage known as the pylorus. This muscled passage at the lower extremity of the stomach also acts like a valve, regulating the movement of semi-digested food from the stomach to the duodenum. It is the rhythmical undulation of the powerful stomach muscles, located in 3 layers, that enables food to move from the stomach to the mouth and to the pylorus. This undulating movement also churns the food over, kneading and pressing it, and thus enabling it to be ground into small pieces, and eventually to be converted into a semi-liquid mixture known as chymus. The digestive process in the stomach is different to that in the mouth. Powerful acids go into action in the stomach. As soon as the food descends to the stomach from the esophagus, cells on the stomach surface begin secreting a fluid known as gastric acid. At the same time, chemical milling fluids by the name of pepsin and hydrochloric acid are also released. These acids in our machine are strong enough even to digest a razor blade. They are essential for substances that are hard to digest, such as protein. However, there is a very important detail here. The stomach itself is made up of protein. So how is it that an acid capable of digesting a razor blade does not damage the stomach? This is another example of the matchless creation in the human body. The stomach does not digest itself because of the depths of its corrugated walls. There are cells with different properties in the deep folds of the stomach walls. These operate in great harmony, some secreting acids, the other giving off a sticky fluid. This fluid, known as mucus, coats the surface of the stomach and protects the stomach wall against the acids like a shield, and prevents enzymes damaging the stomach. In addition to destructive enzymes, mucus also prevents infectious viruses and other microorganisms from entering the stomach, as well as acting as a lubricant that make it easier for food to move along inside the channel. How do these processes take place, and how does this protective environment in the stomach come about? Could the cells in the stomach have spontaneously decided to produce these protective substances, and in some way have discovered their chemical formula? That is, of course, impossible. Then again, let us just consider what the cells would need in order to do such a thing. In order to produce the substance required for digestion, various cells would first have to be aware that food needed to be digested. Those same cells would have to know that a substance such as acid was required for digestion to take place. Later on, The cells would have to discover the most appropriate acid formula and engage in production in the light of that. In order to produce a protective substance, various cells would first have to determine that this acid could damage the stomach itself, and then examine specimens of that acid in a laboratory and develop the formula that would neutralize the effect of the acid. That acid is so powerful that even one single drop can burn a giant hole in a carpet. For that reason, we must not forget that any error in the formula would result in the stomach being dissolved by its own acids. The valve at the entry to the stomach prevents the acid from escaping and from harming the esophagus. Were it not for that valve, or if it did not work properly, acid will leak into the esophagus and tear it apart. Indeed, in diseases such as gastritis and ulcers, the mucus layer does weaken, and serious damage can be inflicted on the lining of the stomach. Naturally, the formation of the substances that so balance one another in the stomach is far more complex than the summary provided here. Even the regulation of these substances' chemical formulas is a major phenomenon all by itself. There is, of course, no possibility of a cell establishing chemical formula, bringing them together, and thus producing a chemical substance. It would be completely irrational to maintain that a cell consisting of unconscious atoms possessed such intelligence and abilities. Furthermore, even if we did exceed the bounds of reason and logic by assuming that the acid in the human stomach did emerge in such a way, there can still be no question of waiting for the substance that will balance it to emerge over the course of time. This is because acids, strong enough to melt a razor blade, would quickly destroy the stomach. It would be impossible for acids to remain unchecked in the stomach for even 2 to 3 days, let alone millions of years. Bearing all this in mind, we are confronted by one inescapable fact. The coexistence of the acid and the mucus that protects the stomach against it is just one of the countless examples of the order and perfection in Allah's creation. Allah has created the human body as an integral whole with a flawless structure. This is not the only example of planning in the working system in this machine. So perfect is the system in the human body that precautions have been taken against all kinds of possibilities. Digestive acids inside an empty stomach will soon damage it. For that reason, the stomach contains no acids when it is empty. The danger of damage being inflicted is thereby eliminated. The empty stomach contains an enzyme known as pepsinogen, which has no digestive properties. When food enters the stomach, however, the gastric cells begin secreting hydrochloric acid. This immediately alters the structure of the pepsinogen, converting it into a very powerful destructive enzyme called pepsin. This immediately starts working on the food in the stomach. There is obviously a power that knows when the stomach cells should secrete which substance, that enables the cells to go into action in just the right way, and that regulates the timing of the acid secretion. This power in the human body is Allah, who created the entire universe, who created all the living things in it, and who created all human beings. Allah has no partner in the creation, and says the following about those who adopt other gods than Him in the Quran. I seek refuge in Allah from the accursed Satan. Do they make things into partner gods which cannot create anything, and are themselves created, which are not capable of helping them, and cannot even help themselves? There is great activity where the milling process is carried out. Enormous hustle and bustle begins in your stomach shortly after you eat anything. Your stomach constantly churns to the right and left, upwards and downwards, and strives to ensure that food is well digested. However, thanks to the special suspension system in the stomach, you are never aware of this motion. The stomach muscles are arranged in 3 separate directions. This means that the stomach is easily able to move up, down, and diagonally. Food thus makes better contact with the gastric juices. However, movements of this kind always bring a danger with them: friction. The systems in our bodies are not limited to digestion. There are other systems and machines alongside the machine under discussion. It is essential that this movement and the friction resulting from it should not damage these systems. The stomach is an organ lying more or less alongside the intestines. Its constant motion will mean friction against the intestines, something that could lead to serious problems for human health. Naturally, a precaution has also been taken against this danger. The outermost layer of the stomach is coated with a membrane known as the peritoneum. A viscous fluid released by this membrane performs a function that can be described as the external lubrication of the stomach and intestines, oiling these organs and thus preventing them from being damaged by rubbing against one another. The process of breaking down the substances that emerge from the main digestive unit is not yet finished. Food that has been turned into the consistency of a water paste in the stomach is forwarded through a one-way valve to the duodenum, and from there to the small intestine. Although a large part of the food has been broken down in the stomach, some of the food in the stomach has still not been broken down into its smallest components. These foods that leave the stomach without having been fully digested shortly afterwards reach the small intestine. Fats, for example, are difficult to digest because they are large molecules and are not soluble in water. For that reason, fat digestion takes place in the small intestine rather than in the mouth and in the stomach. 2 organs, the pancreas and the liver, enter the picture at this stage. These 2 organs send 2 special fluids through a channel and into the small intestine. The liver is aware that the stomach has not broken fats down. It also possesses the chemical formula for a special fluid that will perform that task. The liver knows the moment that fatty foods reach the intestine and releases this special fluid it has prepared and stored at just the right time and in just the right direction. This secretion, known as bile, does not just break down fats. It also helps with the broken down fats being absorbed from the small intestine. In addition, it contains special chemical compounds that enable vitamins to be absorbed from the intestine. What is more, it is an antiseptic that kills harmful bacteria in the intestine. The job of this secretion, called bile, is to subject the fats in foods that reach the small intestine from the stomach for a preparatory process. This increases the effectiveness of the fluid emitted by the pancreas. Pancreatic fluid contains a number of enzymes and assists with the digestion of starch and proteins, as well as that of fats. The mucosa that line the inner surface of the small intestine contain a large number of small secretory glands. The various enzymes in the intestinal fluid released by these glands play an important role in the digestion of those foods that have still not been sufficiently broken down. 3 to 5 hours after eating, most of the food in the small intestine has been grinded down. In this way, carbohydrates are converted into simple sugars, proteins into amino acids, and fats into glycerol and fatty acids, thus making them ready to be absorbed. Absorbent cells in the small intestine latch onto food molecules that are ready to be absorbed. They then release these into the bloodstream. No nutrients apart from water are left in the food that is now about to leave the small intestine. They've all been absorbed.